Apparently it's 11. Great. Well, thanks everyone for showing up this morning for our security panel on defending the cloud castle. I'm Sean Michael Kerner. I'm an editor at eWeek. I manage Linux Today, a bunch of other properties, but you're not here to see me. We're here to talk with our panelists about cloud security and everything that goes along with it. When we talk about cloud security specifically in an OpenStack context, it's important to differentiate what pieces we have. There's OpenStack, the project, which has the OpenStack security group. There's the VMT, and Tristan can talk a little bit about VMT, we have that. There are individual projects like Barbican, and Dave here knows a little bit about Barbican. There's the infrastructure that runs OpenStack itself, and Clark will be able to talk a little bit about that. And then there are large operators, and there is no larger operator, unless I'm mistaken, than CERN, and Arne will be able to talk a little bit about that. So we're just going to have about 30 minutes of discussion back and forth. Some of the topics that we're going to talk about were listed on the agenda. But what I wanted to make sure is we have at least 10 minutes at the end, because security is a topic where everyone has questions. None of us are lawyers, so we won't be able to tell you if your cloud is GDPR compliant, sorry. But we will talk a little bit about that, since apparently everyone needs to be compliant by this time tomorrow, theoretically. We'll just start with some brief introductions. We'll start with you, Dave.
Right. I'm Dave McCowan, and I'm a developer at Cisco. I work in our private cloud engineering team, and we help our customers install, operate, and manage secure infrastructure optimized for NFVI. And also I contribute upstream to the Barbican project. I was PTL for the Newton through Queens release, and I continue as a core developer. We've seen a lot of interest lately and an uptick of adoption. So great news and exciting stuff in Barbican.
Excuse me, Clark Boylan. I'm the current infrastructure project PTL for the OpenStack project. My day-to-day is running the systems that we use to build OpenStack, the software. We are in multiple public clouds and semi-private clouds around the world on 3 continents. So there's a lot of diversity in the clouds that we consume, and then we also run and test the OpenStack many, many thousands of times a day.
So hello everyone, my name is Arne Wibalek. I'm working at CERN. I'm responsible for the overall operations of the CERN cloud. And though security is not my primary area of expertise as a cloud operator, of course, this is an important aspect of my work. And if things happen like the Spectre Meltdown vulnerabilities, it's my responsibility to react to this and deploy corresponding fixes in our cloud.
And good morning, everyone. I am Tristan Dicacre. I work for Red Hat, and I am a member of the vulnerability management team, which is in charge of coordinating and managing security issues that are being reported on OpenStack projects.
Fantastic. So we'll start with you, Tristan, actually, because the VMT is different projects, different organizations, open source or otherwise, have VMTs. But just give us a little bit of color as to how the VMT operates, how many people are on there, and how you handle issues.
Yes, right. So the VMT is composed of 3 individuals. It's kind of a cross-project effort. It's not associated with one in particular. It's just that when a security issue gets reported to an OpenStack project, the VMT member gets a notification, and we have to actually look for if it's a critical bug and if we need to assign a security number to it. And then the most important thing is doing the coordination of the to make the disclosure happen in a timely fashion.
Fantastic. So, Dave, when you had issues at in Barbican or whatever, would they have gone through the VMT, or how would those have related? And then same question for you after, Clark, but how it works within the infrastructure in VMT.
Yeah, so it'll happen. A developer or an operator will identify a bug and realize that there might be a security implication for it, and you don't want details of that vulnerability out in the public before the developers have a chance to patch it. So that person would open a bug in Launchpad or StoryPad and mark it as a security impact, and then that bug report would then be embargoed, would be sent to the 3 people in the VMT to evaluate and understand the impact, working with select people to identify that.
Fantastic. And then on the infrastructure side, since you're consuming the projects as opposed to being a project yourself, so you're getting stuff probably from the projects, and then it goes to the VMT and then back to infrastructure, I guess?
Yeah, so well, one of the infrastructure team members is actually on the VMT as well, Jeremy Stanley, and so
All right.
he will often be kind of that bridge between here's something that we need to be addressing in the running software itself. He also is great about just keeping appraised of the general software security global state for the various software that we run outside of OpenStack as well.
That's fantastic. Great. And then in terms of operations, I know, Arne, we were talking briefly before about Meltdown and how CERN had to deal with it. Meltdown and Spectre are, just for those of you that may not be aware, are side channel vulnerabilities, though there's now a new one with a speculative execution vulnerability. They weren't supposed to be disclosed until January 19th, but people in my line of work don't like to wait, so it got disclosed January 3rd. There were 3 types, type 1, 2, 3, and as of this Monday, there's also a 3A and a 4. But for now, we'll just talk about the 1, 2, and 3. But when that came in, and you saw that on January 3rd, what happened at CERN? And then I have to have the standard CERN joke. When you see the word meltdown in CERN, was there a different connotation that you were worried about?
Yeah, it leads towards some jokes.
Yeah.
No, so what actually happened? So CERN usually closes for 2 weeks during the winter break. So that actually was made known when everyone was still off, actually. But then it quickly happened that everyone was exchanging emails, and we're trying to coordinate how to react to this. At CERN, we have a security team that's actually taking care of the security, the computer security of CERN. So we're coordinating with them and basically relying on them to tell us what to do. What actually happened in the end is that we decided to roll this out and shut down the whole cloud and patch the whole cloud, which meant in our case, we had to reboot 8,500 hypervisors, shutting down more than 30,000 VMs, or reboot 30,000 VMs, talk to thousands of users, communicate this, and then execute this campaign.
That's shocking. I don't think I don't know anyone
was
ever rebooted 30,000 machines.
Neither did we. It was actually, so we run this on cloud since roughly 5 years now in production. I think it was the first time that we had to actually shut down everything.
Yeah. And then just from a power perspective, because when you're power cycling 30,000, I would assume that you have a steady state on UPS, et cetera. When you're rebooting, there must have been other alerts that showed up on your dashboard.
Right. I mean, so this was a significant campaign, of course. So what we did is we communicated this to our users, and then we actually we didn't simply switch off everything and brought everything back up again, right? So we did this in stages over multiple days. We started with a very small chunk also to learn what actually would happen if we shut down hypervisors, because it could happen that we shut down like 200 hypervisors and they don't come back. Sure. So we also adapted the procedure that we had, because we were thinking that, for instance, when you shut down a hypervisor, the VMs would be shut down cleanly, which was not the case. So we had to actually adapt the procedure while we were doing it, and we were in close contact with the users, got user feedback, hey, my machine doesn't come back, my file system is corrupted. But then again, we're in the lucky situation that in CERN we have teams that can look at specific issues. So we have a sysadmin team where we can outsource, hey, this doesn't come back because of a grub issue. And then over time, so with each day, we basically rebooted one availability zone. We announced this to the user, and then we responded if they had like special machines, and that we did in a specific time window. But we basically did it in like a week. We rebooted thousands of machines.
And then, because everyone loves talking about automation, the last question I've got for you on this is, did you automate the process, whether it was with heat templates, Puppet Chef, Ansible, or otherwise?
No. This was mostly, so it was
real humans.
Yes, it was real humans. We have some tools actually to like talk to hundreds of machines, of course. So it's like a parallel SSH thing, but it was actually me and my colleague Jan. We were basically doing this more or less manually.
A lot of lost nights.
There's no automation for like something like this. As I said, it was the first time, and
so when you see press releases or things in my line of work where people say automate everything, you see this guy and you think
Oh, no. Look, wait. It doesn't mean no. It doesn't mean that we don't automate at CERN.
I know.
Many of the things are automated, but this special thing we didn't have time to actually like invest into some automation.
It's not a deterministic process, as
exactly.
it were. And then from the OpenStack infrastructure, how do you guys deal with it?
Yeah, so we kind of have two sets of major control planes that we operate. The first is the Garrett Jenkins Zool CI. We don't run a Jenkins anymore, but it's that control plane. And we very quickly rebooted all of those. Similarly, we kind of divvied up the work among team members. We did use Ansible to ensure that the patch kernels were in place, reboot, and then check things when they came back. But we still had humans watching carefully to make sure that services were still running in the expected manner when they came back, and that there weren't new behaviors there was lots of concern about performance degradation in particular. So there was monitoring of that. And then we had our infrastructure cloud, which is an OpenStack cloud that we ran ourselves, which had its own control plane. It was running on bare metal, and that was a kind of the top priority as soon as kernel patches were available for that, because the concern there was we were running untrusted workloads in VMs on that cloud, and so it was important to get that patched as quickly as possible.
And when we talk about patching, because there's the microkernel, or microcode rather, on the CPU, the firmware, the boards, then there's the operating systems themselves that need to be patched, and then there's probably, I would have assumed, some Nova updates as well, or perhaps not. So were all those things needed to be patched?
So in our case, yes. However, the primary concern was the initial page table isolation for Meltdown, because that was what came out first, and that was just in the kernel itself, reboots. The actual CPU microcode came later, and by that point, we no longer had access to this hardware, so that was kind of like a no-op for us. However, for individuals running hardware, it was something to be considered. And then working upstream in the community, a couple of Nova developers added a feature to Nova to allow finer grained control of CPU feature flags, so that operators of clouds could restrict access to the potentially more dangerous parts of the CPU, and to mitigate performance impact of the patches.
Fair enough. And then Dave, when you think about it, either from a Barbican perspective or perhaps even from the broader Cisco perspective, because I know Cisco, people in Cisco at least, were part of that early disclosure and embargo, how did it trickle down to your level?
Yeah, not so much on the development side, but definitely the lesson learned is to plan for any eventuality. When you think about architecting your cloud and planning your tools and picking your tools, know that you might need to patch or replace anything in the system from the hardware up.
Yeah, because when I think Barbican specifically, I think certificate management, and I know in another incident, Heartbleed, the OpenSSL incident, some people told me you have to reissue all your certificates to be safe. In this instance, since we don't know if somebody took advantage of the page table isolation, Meltdown variant 1, was there a recommendation at all from Barbican that everyone should reissue certificates perhaps, or would have been too painful?
It seems like a good idea.
All right, fantastic. And then Tristan, from a VNT perspective, when a new thing comes in, whether it was the 3A now or 4, what's the triaging process for vulnerability as it comes in, whether if it was a Spectre Meltdown type thing now?
That's a good question. So for those type of issue, the first thing we look at is there really something happening in the software that is being produced within the OpenStack project. So in the case of those hardware issues, unfortunately, there is nothing we can do to help patch this. So there are some patch in flight in Nova to add those extra protection, but it's really the issue should have been fixed by now. It's more like to prevent further problem regarding to those bugs, but. Yeah, we won't be issuing an advisory per se because it's not a bug in the OpenStack project.
Got it. And then similarly, like when we're talking some of the new ones, type 3A and 4, which is a speculative execution, they say it's performance impact as opposed to something else. So that wouldn't necessarily come through the VMT either, I would guess.
Yes, and moreover, we have to ensure that the fix, that those security fix, when they get applied to stable branch and for operator, if they change default behavior or if they need like a new configuration settings, they won't go through our channel because we want a user to safely take the fix that are being worked on as part of the VMT to be as stable as possible. So in particular for this one, because it induces performance degradation that might have been like discussed more thoroughly. So.
Got it, good. And then, because I want to make sure we talk a little bit about compliance stuff, from an operator perspective, Arne, when you're looking at GDPR and you've had to deal with privacy by design and the ability to forget things, I guess. What sort of constraints or requirements did you have as an operator where you're looking at implementing GDPR across the CERN OpenStack cloud?
So actually we started with implementing GDPR quite a while ago. So we had actually someone or a team actually looking at this because that's like pretty important. And then for the individual, we went through the individual OpenStack services one by one, basically looked at what kind of data they store and where they store it and how we handle this. But this is mostly what we did.
So it wasn't just looking at Keystone and then looking at the various
no,
making sure they're isolated?
It's also all the other services that may put something into the log. So it's like, for instance, like how long do we keep the logs of certain things? Where do they actually go? Because we have, for instance, central monitoring where all log files are sent to. So it's not necessarily in our control as the OpenStack operators where these logs actually go to. They go to some Elasticsearch, for instance, or to other systems. And we need to make sure that actually this data is handled properly.
And I would assume as part of that, because I know CERN is obviously an operator, but also a large contributor as well, I would assume that there were multiple fixes and multiple projects that had to be made upstream?
I don't think so. It's mostly mostly configuration.
Mostly configuration?
Yes, in our place it's mostly configuration, like, as I said, for instance, for logging, and to understand which data is actually where and how long is it kept.
Got it. And then Clark, I know you're an interface to multiple clouds, so you've got a little bit of a different perspective.
Yeah, well, so for us, it was less about the clouds themselves and the services we run on top of them. But being a community-run infrastructure, we already kind of have, I don't want to call it privacy by design, but we're already fairly cognizant of the fact that we need to protect this data because it's ours. We're not a company, or we're not hiding anything, or how to put this politely. We're not using your data in nefarious ways, and the way we do use it is completely in the open from the start. And logs, for example, we already have a very short rotation on those. So in large part, I don't believe we've had to address any particular concerns. The upstream Garrett project, which is one of the bigger services we run, has been poking at ways to make compliance easier, but it would be a matter of updating user account data out of band if requested at this point.
And I know at one point, and it's still around, there was the OpenStack Congress project, which was more policy kind of stuff. Was there any efforts to look at some kind of policy-based project in OpenStack or otherwise to help with the infrastructure?
I'm not aware of that. There has been a recent thread started by Graham Hayes.
Okay.
If the name's right. Talking like at a larger global OpenStack arena. What are the things that we should be doing in regard to this? To make the configuration changes easier. Whether that's documentation so that people know what to do without figuring it out themselves.
Right. Also harmonizing configuration, because like for each project it's somehow different at least for different distributions, also different how long logs are kept. For each project it's different.
Yeah. So it's not just one item that I'm going to find in my Horizon dashboard that's going to be a specified configuration then. It's multiples, or does it surface up to Horizon at some level?
It does cross all of the services, because it's service-specific logging is one of the key areas, and then, for example, with the DNS service, SOA records have to have an email address in them, and so there are very specific pieces of information tied to specific services that would need to be.
Because I know also the Ceilometer project was supposed to be for some monitoring. I know Tacker does other side on the NFV side, but could Ceilometer have been used for aggregating all those logs and then surfacing it in that way as a configuration?
Not Ceilometer itself. That's more metrics, which ideally don't have that personal information in the first place.
Okay.
But they have been. Searchlight was a project. I don't know how active it is, but its purpose was to aggregate data like this, logs, events from your various services, and handle it in a central way. So that may be an avenue to address this.
Got it.
It's also like, so for logging, this is one thing, but the other thing, or as you said, Ceilometer was more for metrics, but there's also things like what's happening in the databases themselves of the various projects, how long is it actually kept, who logged in when, how many resources does someone have, and how can you correlate this with accounts and identify who is actually using this. So this is also something that we needed to look at.
Got it. Good. And then, go ahead there.
So from a Barbican point of view, regulations like GDPR and also ANSI has been driving interest in the project, and also new requirements. The ANSI especially has a requirement to keep the key manager, the key administrator, and the data administrator separate. Having a key manager separate from sender helps meet that requirement. Also had some interesting requirement discussions this week. People saying encrypt all the data, and then if it needs to delete something, you can delete the key. And maybe that could be a requirement to Barbican to help enable deletion of data.
That's great. And I know you were in multiple Barbican sessions this week and the like. Is this the first time you've heard GDPR this week, or is it something that has been a topic in real technical discussions, or is it just, media types asking you?
I hear requirements from customers. It's mostly around ANSI, but I think GDPR is kind of a close brother in the EU.
Fair enough. Great. And then for users, and I'll ask you this first question, Tristan, what should users and people be thinking about in terms of OpenStack security when they're thinking about how they want to report vulnerabilities, or what they should be doing, and how they can help you and the VMT team, whether it's OpenStack contributors, operators, companies, or otherwise?
Right. So to tackle those issues in the future, it seems like important things to grow security awareness within each of the project, because they kind of like have their own threat and assessment. So in the past, the OpenStack community have been pretty good at fixing issue in a timely manner, because there are like in each project there are a few dedicated people that the VMT can engage with and figure out how to fix those issues. So I think the one way to address like future issue will be to be that each project and each deployment have like dedicated people working on the different components. So that sounds a very important things to have.
And then when you think about it, Arne, in your organization, I know there's a separate security team, but are there things that they're asking you that they need from you and your side of the business?
Yes, they are. So of course, so we rely on the security team to actually understand the vulnerabilities, because there are experts that actually can tell you how to exploit these, or how realistic it is that someone exploits this. So we also assess the risk of a specific vulnerability before we actually deploy a fix, also because we have, for instance, hypervisors that are on private networks and this kind of thing. And we also, on the other hand, we also give the security team tools so that they can interact with the cloud. So for instance, if they detect something that's wrong, they can, for instance, I don't know, lock an account or freeze a VM or take a snapshot of a VM, just like to keep the evidence, if you like, and analyze this offline. Yeah. So there are actually some things that we allow the security team to do.
And then from your side, when there is an incident or something, does it usually show up that a user's complaining and it comes through help desk, or does it come through security? Or
you mean when the security team actually froze something? No, usually it's the security team. So the security team has means to actually detect that something is wrong. For instance, I don't know, there's like abnormal network traffic or something like this, and then they basically contact us to like give them all the information they need for this, and then they basically, for instance, take a snapshot of the VM. But it's usually, okay, I don't remember that we ever had a case where a user was complaining afterwards that his VM doesn't work anymore. Usually by that time,
I'm thinking
it's
more
probably
that
pretty
somebody
late.
calls in on the help desk and says, hey, my password doesn't work, and that's because they just clicked on a link for something else and somebody stole their access.
This I don't know, this I wouldn't see, because probably what the security team does then is they lock the account, so it's possible to lock accounts centrally. But then if the account doesn't work anymore, they would open a help desk ticket, and help desk would probably handle this. I wouldn't see this anyway.
And how are you dealing on the OpenStack infrastructure?
Yeah, so for us, there have been kerfluffles, I guess, in the past.
That's a nice way of saying it.
We're similar, where either our cloud provider or an individual will notice, this host or the service isn't acting properly anymore, and will typically it's shut it down as quickly as possible, work off a snapshot. An example of that was an Elasticsearch server was once left open on the internet, and it turns out that only takes about 3 minutes to get owned. Thankfully, it was on a dev server.
3 minutes.
Yeah, it was fast. It was on a dev server, right? This was a sandbox environment from the get-go, but I think it did help reinforce with the rest of the team, like you have to be careful, and layers of security are important to avoid these issues.
Got it. Good. And Dave, what are you saying?
Yeah, so say from as developers, I think we need to do a better job with secure defaults and secure documentation. As engineers, we like to focus on our task at hand, so we simplify everything else. And so we'll turn off SE Linux and turn off TLS, and Just make everything as simple as possible, but then that trickles down through the way we do our functional tests, the way we do our documentation. And,
Yeah, well,
and operators are left starting from square zero to make it secure.
sure, when the file doesn't run, they just chmod 777 and away we go. Everything magically works, right? But that doesn't work. When I think of OpenStack, OpenStack by default is not necessarily secure. It's more of a DevOps thing, and then it is the secure configuration. Just as a theoretical question, would it make more sense if the mainline upstream was secure by default, where SC Linux or SecComp, well, SecComp is a little bit trickier, AppArmor was by default on the operating systems, et cetera? Would that be a direction you would embrace?
As an operator, I would be demanding it.
Yeah.
As a developer, I'd reluctantly work in that direction.
Okay.
And I think some projects are working in that direction faster than others.
If you guys want to comment on that, too, by all means.
Sure. As far as like SE Linux goes, we run some of our services run on CentOS machines, and for those, we've been really good about we're going to have SE Linux on and enforcing, and we'll do the work that we need to enable those services to run. It's a little bit more difficult with other systems like AppArmor just because it's different, and we don't have the knowledge base there. As far as on the OpenStack community side, I know a lot of the testing, like you say, you make it easy for development, but on the distribution side, I believe like Red Hat has SE Linux rule sets for all of OpenStack that they deploy. So there is work in that regard, and it is useful. Like I said, when we run services on platforms that support SE Linux, we do our best to make sure it's there and enforcing.
Right. So it's the same at CERN basically. So we have SE Linux, of course, enabled and enforcing everywhere. From time to time, there are like little issues where something doesn't work, and then we sort this out. But we would not like switch it off globally.
Good. That makes sense. Great. And then I know, Clark, you also wanted to talk a little bit about security groups, because apparently you have an opinion on them. And then perhaps you just give a little bit high level on security groups. For those of you that run AWS, you're used to security groups, but it's not a common always-on idea in OpenStack, if I understand correctly.
Yeah, and I think this comes back a little bit to the idea of security and layers is useful. Security groups, some clouds don't have it enabled as a feature at all. So as a user, you're not able to make use of the feature. In other clouds, it's there, but the default rules might be to be open to the world. The upstream default is actually what I would consider secure by default. Only instances within a security group can talk to each other, and nothing else is allowed in by default from Neutron, which is great. But from an operational perspective, it's really, I think it's a great way to have like a broad statement of what your security stance is from a network perspective. Like, if you know you're running web servers and there's a database server in there, you allow that specific traffic, and then you can fine tune beyond that. But at times it can be complicated to use it as that fine-tune tool, because you can't get logs out of it as saying like, was this traffic blocked because of a security group? That's not something that is easy to find out, if at all, unless you're the operator of the cloud running.
Now, for the OpenStack infrastructure group, is there or would there be a direction for a best practices, white paper, otherwise, to define how you guys are doing the security policy so others could benefit from that?
Maybe. So we actually take a slightly different approach. Because we run in clouds that don't allow security groups, it's not straightforward for us to use it in some places and not in others, just from a mental mapping space of like, if I'm debugging this problem, I'm going to forget to look at security groups if they're on, because elsewhere I'm never going to look at them. So the approach we've actually taken in that way is to have strong controls on each individual host that we run in the cloud.
Then how do you maintain consistency across them, since you're on multiple clouds?
Configuration management and using IP tables is a really important tool to us.
I thought everyone was supposed to use Cilium now.
And net filters but yeah, I think it would be great if security groups were a little bit more of a usable tool, like in clouds, that you could rely on it, and being able to get logs is a very important thing for debugging.
Absolutely. And at CERN, Arne, from an operator perspective, are you enforcing them? Did the security group tell you had to put them in place, or is that not something?
No, so the network so at CERN is a little bit special, because the network infrastructure at CERN is relatively simple. So it's basically a flat network. There are no segments is not fully correct. So we have different networks, for instance, in order to control the accelerator. But for what concerns the cloud, it's basically like one big flat network. The hypervisors are on private networks, and then there's the firewall around the virtual machines. But they all have like connectivity basically to the internet, for instance. So we don't have security groups, but we're also in the transition between Nova Network and Neutron at the moment. So all of this makes things a little bit more.
You're still running Nova Network.
Well, yeah. Well, yes.
I was under the assumption
so we're in the
that it
transition
was,
to Neutron, but it's complicated because we have
the things you learned from a panel. I was under the assumption that Nova Networks was deprecated 2 years ago.
Oh yeah, it is. So we were like arguing this week that we should keep it for another release or two.
So if Nova Networks is deprecated and a vulnerability goes to Tristan and the VMT team, but since Nova Network is no longer supported, what do you say, Tristan? Do you just say it's your problem and that's it, or how does that work?
Be kind, okay?
But it's difficult in those situations because yes, if the code is no longer supported, that means there might necessarily be developer aware of how it works and how to fix it. So I think that if someone wants to run like unsupported code, then they probably have the knowledge to fix the issue if it arises. So that's how it will go.
Yeah, fair enough.
And back to the question about being secure by default, it seems like a complex topic with cloud software because not everyone have the same security boundary and expectation. So some people, they might want if it's run internally, they might want more access to it, and while public cloud, they have different needs. And even for security groups, like, yes, they, by default, Neutron will prevent any inbound traffic, but some user may say that outbound traffic is also an issue, so then we want the thing to be, there is a tight balance between usability and regarding at least default settings. So.
Sure, and then the other step beyond that is something like, no pun intended, but Google's Beyond Corp, where it's zero trust, and all nodes are untrusted, and you have to authenticate everything. Is that a direction that, as a security guy, you like?
Well, regarding the vulnerability management effort in OpenStack, we make sure that the feature at least worked as advertised. Like if a security group is supposed to prevent traffic, then if it does not, then that's an issue and we will fix it. In that sense, we'll make sure it's secure. But then it's really up to the operator that really needs to be conscious about how they consume and deploy those software.
Got it, great. We have about 10 minutes left, so if anyone has questions, we've got mics on the side. You can ask any questions you like. Don't be shy. If not, I've got more. No questions yet. Okay, great. What sorts of things, and I'll start with you, Dave, what sorts of things, what priorities should users have for hardening their security when you think about things? I remember a couple years ago, nobody was using Barbican, which I thought was kind of surprising, but you told me this week there was a lot more people in some of the onboarding sessions.
Yeah, and the user survey, I guess it'll be coming out soon, but the last one had up to 20% adoption, which with the big uptick. It's hard to pick one security topic as the highest priority because the hackers will just find whatever the weak link is.
Yeah.
So definitely look at security and layers and start by hardening the hardware and the operating system configuration and a secure OpenStack configuration for the infrastructure, and don't forget about the workloads too, and make sure you don't give untrusted users opportunity to run untrusted code.
Even in a flat network like what Arne is running?
Yeah, you got to look at your use case, and if you don't have a requirement to let people do anything they want, then, don't give them that requirement.
And just as a curiosity, are you running Barbican inside?
Yes, we do.
That's fantastic.
I was going to mention, as a developer infrastructure for OpenStack, our job is to run untrusted code from untrusted people, which does pose an interesting security concern. And so we do as much as possible to isolate that specific workload into its own tenant, into it, and running on their own images that have relatively locked down. Like there's a single user there, the IP tables firewall is enabled by default, and the only thing in is SSH. And so we're trying to build those layers around this because we know that they're not necessarily trusted users. It's individuals. Anyone can contribute, right? And that includes people you don't know or from anywhere. And then we're executing that to test the code before it's pulled into OpenStack itself.
Well, at CERN, for instance, for our users, I mean, CERN is a very active and very agile environment. We have lots of users coming and going, and most of them are also technically very skilled, so they write their own operating system and their own microkernels and all. But so this is maybe from a security point of view, it's a disadvantage, but also that we have the advantage that our users are usually very friendly. So it's not like we offer something where we have like customers that are on there and trying to break the system. Usually they try to use the system in order to do mostly physics, of course.
So you don't have one user that's trying to consume all 200,000 cores so that they can do something?
Yeah, of course they try to do this, but in a friendly manner.
In a friendly manner. We have a question. Go ahead.
So the vast majority of our security incidents have not been related to OpenStack. They've been application code, for example, maybe by 100 to 1. Is that what you guys typically see?
I would say yes. At least in our, from what I can say, from what I learned from the security team, it's mostly this. There's of course the security team, for instance, does like regular port scanning in order to identify applications that people have installed or we have installed. I don't know, like memcached. Does it have ports open to the world, and you could like grab the tokens out of memcached? So I would say yes. So that's at least function, I think.
Yeah, I think for us it's similar. The applications we run on top of OpenStack tend to be more problematic. The cloud operators themselves tend to be fairly conservative, and they make changes that are very measured, and they try to be secure by default as much as possible. And so it's a common one for us in the past had been like Jenkins, for example, which had a recent major a few months ago. And so the applications like that, which maybe are moving faster and come from a place that's a little bit less conservative about a security stance.
For me personally, when I write about data breaches and stuff like that, you never blame the application or the infrastructure. We always, operators, not you guys, always blame users. The user clicked on a phishing link or something, and the user had been granted permissions to do something they shouldn't have been done. There might have been an application vulnerability that allowed for privilege escalation, and then they own the cluster. But 10 out of 11 times it's blamed on the user because humans. So, sorry, I interrupted if you guys had other comments on whether applications and how that fits. But for the VMT side, you're only getting for OpenStack projects. So if it was an application running on inside of a Nova instance, that wouldn't be a VMT issue at all, would it? Because the VMT isolation boundary should have isolated that sandbox to begin with, or that hypervisor boundary.
Some users do try to report issue with their system that is not OpenStack. So in that case, we can't really help them. So.
But sorry, to jump on the question, what about things like I just mentioned, like memcached, that's like deployed very often along with OpenStack?
Yeah, so we make sure that the managing security on deployment and deployment tools will be very tough for our small team. And I think it's really another topic, and it will be like too much decision to take about, okay, so should this service be really protected? And is there a use case for user? Will it make sense to have it like more available? So this is where like the expectation it will be a different, I think, type of processing for the bugs. And regarding the current API, it's true that they have been well audited, and the traditional API seems to be like pretty robust nowadays. But maybe like for new features, there might be like some issues. So what's happening then in those cases is that if the bug is detected during the development, because users are like experimenting and making sure the feature works properly, in those cases we won't even issue an advisory because it's like unreleased code. So the bug should get fixed more and more even before the release. It's a good thing to know that OpenStack is not at fault in the case where at least one time out of 100. So.
Yeah, with memcached in particular, because that came up to my level where I write about stuff, it was because of the amplification, and there was memcached everywhere. And when you do the basic showdown search, which in my line of work you just do, and you say, oh, there's lots of it, it usually doesn't tell you that it's an OpenStack cluster that it's running on, or it'll tell you if it's AWS, but OpenStack, it doesn't show up in some of that header data. We have about 2 minutes left, so if there's any other questions, otherwise we'll just have some final remarks. Any other questions? Going once, twice? We'll just start with you, Dave, and we'll go down the line. What do you see as being next for what you're doing with OpenStack security, and what's your hope when we talk about this again next year, if not later this year?
Yeah, well, I think we're going to be busy with Barbican because I think people are becoming more aware of risks to their data. So I think we're going to see more more requirements for encryption, and as Barbican adopts, there'll be more plugins is something we've gotten requests for. People like HashiCorp Vault to store keys, and we've got a lot of requests. It's like, hey, can I use Vault with my my OpenStack cloud? And so Barbican and Castellan will add some plugins to interoperate with that, and I think we'll see that in the future.
Yeah, that's really important. And just as an aside for that, nobody should ever hard code credentials or access credentials in their services, because it's really easy. That's why something like Vault or an external store is very, very important.
From us in the OpenStack infrastructure project, a big part of it, I think, is we're continuing to improve and get better at isolating those workloads, the untrusted user, untrusted workload. And we're learning how to do that. We've been doing that since the beginning, and we've had recent kernels have made that a little bit easier in some ways, and then of course the bugs that might make it a little bit more difficult. But I think a lot of the focus will remain around that for our specific sphere of the world, and making that easier to manage and handle. And
then just one quick follow-up for you, because you're OpenStack infrastructure, since I know you're running Zuul, I would assume that you're looking at Kata containers also. Is that part of the plan to help secure when there are container deployments on infrastructure?
Not yet. So we're still trying to figure out just the containers as a container. I think as a user, a Kata container would be useful in that context, but that's like step 2, and we're still on step 0. However, we are isolating sandbox environments for the execution of the Zuul executors in Bubble Wrap, which is a project that Tristan's worked on in the past, to kind of have another layer on top of, we're running in a VM, we're then running in a Bubble Wrap context, and then we are running a lockdown Ansible as well. So there's multiple layers of security there.
Great. What's next for you, Arne, other than discovering more quantum singularities?
Given the announcement this week about V4, I will hold my breath whether we have to reboot the whole cloud again. But in addition to this, we will look into things like we just deployed encrypted volumes with Barbican last week or 2 weeks ago, and we're also looking into scanning containers, doing static code analysis. Sure. So this is a project that we're going to do in order to help with security in our cloud.
Great. And what's next for you, Tristan, in VMT?
Well,
or Project Bubble Wrap?
Regarding upstream and community effort, ideally we should keep on growing security awareness amongst each project, so that we are able to fix the issue in the right way. And then on the operator side of things, I guess being ready to roll out the patch we craft upstream to fix if issues arise.
Great. Well, thank you for your efforts on the VMT. It's a small team, but that's a critical job. And thanks to everybody on this panel. Thanks for running infrastructure. Thanks for Barbican. Thanks for not opening up a black hole in the middle of Geneva. And thanks everyone for coming. I think we're out of time. And thank you.